Okay, people, in the space of ASP.NET Core, we have about a bazillion and one ways to secure our resources in our applications. This is method 172,393. Let's mash on that.
Hi, everybody, and welcome to episode number 39 of the ASP.NET Monsters. That's right, this is episode 39, almost episode number 40, which is a large round number. In today's episode, we're going to take a look at how to use access tokens to secure an API. Take her away.
Yeah, that's right. So we've just kind of been experimenting with some of the deeper elements of the .NET framework and what's available in ASP.NET Core. And one of the things that kind of crops up is this idea of security. It's kind of an important thing. There are some resources, though, that aren't like we don't access them in the same way. So for example, if I am coming at a website, I've got the ability to enter a username and a password, and we can securely negotiate the user's login. However, if I'm coming in with an API, then we might want to take a different approach. And in particular, if we want to allow access to third-party APIs. Now, in this particular case, the scenario that I was trying to solve a problem for was where we had a resource that was already protected, or a set of resources that were already protected by the built-in user management, by the built-in identity in ASP.NET. And I wanted to allow third-party scripts to access some new data that was being made available via APIs. So the typical thing that happens when we've got an identity provider is we might do something like redirect the user over to the authentication store and have them log in. They can pass in, say, for example, a username and a password, or an API key and a secret of some kind, effectively the same thing. So there's a username and a password. And in exchange, that third party is going to give them a token back. When they come back to our application, we accept that token and then we verify with the server, because we don't trust the user. We want to make sure that it's not something that's been forged on the way in, and try and prevent forgery here. So the token comes from the server back to the client, which in this case might be another service, and that service is then going to call in to our application. We take that token from them, and in turn we go back and we ask the origin of that token for this user, is this a valid token, or whatever the case may be. We may go searching for a set of claims and whatnot. In my case, because I've already got the ability to do claims locally, I've already got users, I don't need to go through all of those steps, but I can protect resources using the same mechanism with using tokens. This might be a little bit of an edge case to try and do this, but it demonstrates some of the inner workings of the application. So, or of the security and using tokens and whatnot. Kind of emulates what we'd be doing when we're talking to a third party. So one of the things that I've got set up here is that in on the home controller and index, I'm kind of faking out that process of creating the user token. We'd probably want to do some kind of sign up page where the user goes in and they request access, and then an administrator would go in and add some claims to them, for example. But in this case, we're just doing kind of a self-service kind of thing. So the user comes in, and we're just going to set an authentication token for the user using the actually the user manager. So I've got that injected in via dependency injection. The .NET framework, the ASP.NET Core, that takes care of for us. This is already in the pipeline and configured for us without any additional work off the default template. So the manager here, I just take a reference to it, and inside my index method, I use the manager to find the user, to generate a user token, and then to set the authentication token. Now, the user manager is configured to use entity framework, and then therefore all of the tables required are generated on the fly for us. So we can see here that I've got this API auth, and there's this table here and a user ID. Now, I'm actually going to this value will get overwritten, so I can take that and we can make sure that's the case, but I will just copy this to the clipboard really quickly, and I'm going to paste it there. We'll see that it's changed in a second here. So when I generate a new token, that's going to change, and this value will be different for subsequent requests, so we can actually test this with anything that allows to send headers. I'm going to use Postman when we actually try this out. Okay, so again, here's the flow. We're going to come in on index and we're going to fake the token. And then from there, we're going to do some work manually. And we're going to look at how this is actually protected. So first of all, I will run the application.
So the idea here is that your application is providing an API for some other third-party application to call into, right?
That's right. So we've got our own application, and users can do things inside of our application. But for all intents and purposes, we actually don't want that to be. We don't want to. We want to open up some data to a third party, but we're not giving them access to the source code. We're like, it's just a third party calling into our web service.
Okay, and it will, when it does that, it'll assume the identity of the user that's generated the token. Is that how it works?
We could go that route. There's a couple of ways that we can do it. In this particular case, we're just going to pass in the token and the user information, and then we can verify, if we wanted to, we could verify that that user has claims. I'm not actually signing the user in when we're making service requests. We've actually got some custom middleware that we've got in play.
Oh, okay. So it's not that this is, well, I guess it is a way that you could generate a token for a specific user to interact with the site, but here you're just kind of like generating a token that allows access to the API, not as a specific user.
That's right. Okay. That's right. Okay, so now in this particular case, I'm going to just run this code again, and we should see, because I already ran that that index method, we can see that the token's changed here at the end. So I'm going to copy this nice long token value in here, and I am going to go over to Postman. And first of all, I'm just going to take this, I'm going to clear this out, and we're going to send this request to the site, API data, and all of the values come back, even though I don't have the API token. That's because I haven't configured my middleware. So I'm going to paste that new token that we got in here, and we're going to request it, and it's going to work. Again, we don't have the middleware in play yet, but here's what we've got: an API token and an API user. So this could have been, you know, more like an API secret that you use. Again, you might want to do a more elegant config when you're actually generating these things on your site for your users. That's kind of that's kind of bigger than just the scope of what we're trying to demonstrate here. Okay, so the custom middleware is called token protected resource. I've got a constructor on here, and I've got an async task invoke. This takes in HTTP context like it would for any other middleware, but I'm also injecting this user manager of application user manager. Okay, so what I do in here is I check to see if, you'll notice in my constructor here, I accept the request delegate next, and I've got token protected resource options. That's a custom class that I have that has a couple of properties on it. We'll have a look at that in a second. One of those properties is path, so I check to see if we're actually in the path that we are trying to protect with a token. And then I do a check here, and I say if the headers contain, if they do not contain the API user and the API token, then we're going to throw them back out. We're just going to say, sorry, you need to authenticate, and that will be it. And we can test this in the browser when we restart the application. I'll sign out and we'll have a look at it. Then the next two things that I do, I know that I've got these header values, so I pull them out. And so we do that that step there where we check to make sure that this is a valid scenario. Now, I might do this with a third party. For example, if I'm authenticating against GitHub or something like that, I might do it in that context. But here what I'm doing instead is I just grab a copy of the user. Now, at this point, because I have the user, I can actually do things like inspect their claims, and I can say, is this user allowed to access the API, or whichever slice of the API that I want to. I can split that up by using this options object that I create, and protect different paths in different ways, and then use claims appropriately. I then check That's the call into manager. I just do a verify user token async, and then I see I'm not using an await here. I totally could be doing that instead. Maybe I'll clean that up before I post this on GitHub. But finally, I say if they're not authorized, then hey, let's punt them out again and return. If we fall through all of that and everything is happy, then we go ahead and we say we basically do the next thing in the chain in the middleware. So this is our opportunity to fail the request if it's appropriate, because we're only inspecting for our current path. And we can fail that via missing headers that we expect, and we can fail that via tokens that are no longer valid. So a couple of options that we've got. Now, let's have a look then at this protected controller. We can see here that we've got this API/data, and it's available via get, and we get some values. I'm just using GenFoo, a library that we use all the time to generate objects, and I'm returning a list of 25 people. That's the default size for a list of generic right there. In startup, this is where I need to add some bits. So basically what I'm going to do is app.use token protection. So this is, I made an extension method that we'll have a look at in just a second, but I added an extension method that allows me to just call use token protection and then go from there. So I'm going to protect the path is equal to, and I'll just do /API, and I will also just give it a policy name. That can be just so we can keep things straight. It helps in debugging and we know which policy we're in and things like that. So I'll just say API access. Now this endpoint, anything that starts with this /API path is going to be protected using token protection. So we'll just pop into the resource options really quickly. One of Simon's favorite things is when you put multiple classes in the same file. So I've done that here just to impress him.
And impressed I am.
Right after I was spelling color incorrectly.
It's got a U in it.
So here I take the path, the policy name, that's that object that we talked about, and then here's my extension method where I take an iApplication builder and a set of options that I want. So this gives me access to do app.whatever, and in this particular case I'm calling it use token protection. That starts up the middleware, that sets up the middleware and passes the options into my constructor. So we can go back to that middleware and we can see here when we invoke it, when this gets invoked, I should say, the options will be passed in along with the next in the chain. Okay, so back to our startup. I'm going to restart this guy. And after it gets going, I'll just pop back to the website. Okay, I'm back on the website. It recognizes who I am. What this actually did behind the scenes is it actually generated yet another key. I probably should have commented that out, and this is probably why you'd have a more elegant solution than just being, using it in your home controller. Probably not a good strategy. Okay, I'm logging out just so we can go and inspect the rest of that, the rest of what we've wired up to make sure that it works correctly. So I want to go to API/data. Now, because I'm not presenting the headers that we expect, it should give us the redirect to the login. So we're going to see that, and there we go. Okay, so that's cool. Now I need to go refresh the key that I'm going to use. And I will just run this again, and it will have changed as we kind of expect. So I'll just grab this from the value here. There's the new one, and I will go and open Postman, and we'll just set this guy up. Okay. Now when I invoke this, I'm passing in my token, I'm passing in the API user, and when I hit send, there's our data.
Cool.
So
And
if
what does
I
that
were to
look
take,
like if you change the token to something else? Just
right, so let's just add a 1 in front of it, and I hit send again, and then that's
there you go.
invalid. So I actually, we probably have a little bit more to wire up here in terms of this is actually returning HTML, and it's 200 OK, so not quite right yet. It's actually redirected us to the login, so
Right.
a little bit more to wire up there, but we did not get the data that we were expecting to see.
Cool. So there's a couple interesting scenarios. Like you said, you're not actually logging that user in. It's just either granting them access to the API or not, based on whether or not the token's correct. But that does give you the opportunity then to revoke access if you needed to for some reason down the road. You could revoke
Exactly.
access to everyone or just to a specific user. And another thing that I think would be kind of interesting is you could actually throttle access to specific users. So maybe
That's
you
right.
have some sort of paid subscription service that allows them to access the data a certain number of times, and you could have different tiers of that based on whatever subscription they've paid for.
That's
You
right.
could do that
And
with this.
that's right. Actually, I believe, Simon, you were saying that Redis cache, if we wanted to do a counter in there, that it would be like it's an atomic counter, so we can enter it in and increment it as, as part of the throttling process. We could actually use a Redis cache to back that or something like that for our rules.
Yeah, Redis is great for like distributed counters like that.
Excellent. Okay, so I did want to show too, Simon or Dave. Actually, you'd mentioned you might be able to do something like invalidate the token. All I have to do is call update security stamp async on the user. So this would actually require them to log in again. At this point, it would invalidate any of the tokens that have been provided for that particular user. So yeah, revocation is pretty easy because we can search for users that are in a certain claim. We can say any of the users that are users of our API. Let's get that list of users from the user manager and then go through and update the security stamp on all of them. Anybody who's logged in at that point, any users who are using tokens at that point, those tokens are invalidated, those users are logged out, and they have to log back in. So pretty easy way to kick them back out of the system. Okay, I think that's pretty much everything I wanted to show here. Again, not a complete implementation, but something that you can noodle around with, and we'll make sure that we put the code up on our GitHub repository.
Great. Thanks a lot, James. And we'll see everybody next time on the next episode of the ASP.NET Monsters.
Cheers.
Bye.